On this 2016 to 2024 Honda Civic with the 1.5 turbo engine, P0172 is a rich fuel system code. In plain terms, the PCM may be seeing fuel correction driven too far rich. The car may run rough, feel loaded up, use more fuel than normal, or sometimes have no obvious drivability complaint beyond the warning light. The broad fault areas can include fuel delivery, airflow measurement, air-fuel sensor feedback, purge vapor entering the engine, fuel-contaminated oil injectors, and only after the rest checks out the PCM. The diagnostic logic here is to preserve the scan data, duplicate the rich condition, then work through fuel pressure, airflow, oil contamination, purge, fuel quality, sensor feedback, injector behavior, and finally PCM judgment. Before troubleshooting, start with the basic system checks and make sure you are following a structured diagnostic approach. Do not clear the DTC and do not reset the PCM at the start. That can erase useful diagnostic information, even if an onboard snapshot was saved. Before getting into testing, look for aftermarket fuel system or engine components, because those can change how the fuel system behaves. If a vacuum pump and gauge is needed during the related checks, the specified tool range is 0-30 in HG, Snap-on Ya 4000B or equivalent, commercially available. Also, if other codes or indicated systems are present, especially around fuel pressure, airflow metering, oxygen or air-fuel feedback, injector control, purge, oil control, or intake leaks, handle those first before chasing P0172 by itself. Start by trying to duplicate the fault at idle. Start the engine and let it idle with no load. For a CVT, use P or N. For a manual transmission, use neutral. Watch HDS AFFB short-term fuel trim. If AFFB is less than 0.79, the failure is duplicated. If that does not catch it, use the onboard snapshot. Record the AFFB value from when P0172 set. Then test drive under the same captured conditions, matching engine speed, vehicle speed, REL TP sensor, and APP sensor. While driving, watch AFFB again. In this path, if AFFB is more than 0.79 during the test drive, the failure is duplicated. Because those two checks use different directions around the same value, follow the path exactly as tested. If the result does not make sense in the bay, pause. Recheck the earlier diagnostic path and avoid guessing. Once the rich condition is duplicated, move to fuel pressure. On the low pressure side, run the fuel pressure test while AFFB is less than 0.79. If the low side result is abnormal, the fault area is the fuel tank unit or the fuel pump circuit, and the next move follows that fuel pressure test result. If the low side is acceptable, go to the high pressure side. Start the engine, hold it at 3,000 RPM with no load. CVT in P or N or manual in neutral until the radiator fan comes on, then let it idle. Run the HDS dye fuel pressure test. The expected result is normal. If that test is abnormal, move into the appropriate fuel pressure diagnostic path before continuing with P0172. Next, check the MAF signal under controlled conditions. Start the engine and let it idle. Make sure HDS ECT sensor 1 is above 158 degrees F, 70 degrees C. The transmission is in P or N for a CVT or neutral for a manual, and all engine and electrical loads are off. Hold engine speed at 2,500 RPM for 30 seconds. Then confirm the HDS MAF sensor value while still holding 2,500 RPM. The normal range is between 4.1G/S and 5.7G/S. If it is outside that range, the fault area is the MAF sensor or IAT sensor 1. Now check whether the engine oil is carrying fuel vapor back through the PCV system. Start the engine and let it idle. Gently pinch PCV hose A, then confirm HDS AFFB short-term fuel trim. The expected value in this check is less than 0.79. If the check is abnormal, find the cause of the fuel-contaminated oil, such as injector-related trouble, Then replace the engine oil and oil filter. After the oil contamination check, perform the EVAP canister purge valve inspection and check for a stuck-open purge valve or a purge valve leak. If you do not have a defined purge valve pass/fail test available at that point, stop and get that test path before making a call. The remaining checks are substitution checks because there is no direct test method given for those inspection items in this path. First, drain the existing fuel, refill with known good fuel, and try to reproduce the failure. If the failure still reproduces, keep looking at other related components. If the symptom or DTC goes away, the fuel is faulty. Next, install a known good /F sensor, sensor 1, and try to reproduce the failure. If the failure still reproduces, continue with other related components. If the symptom or DTC goes away, a /F sensor, sensor 1, is faulty. Then install a known good injector and try to reproduce the failure. If the failure still reproduces, continue looking at other related components. If the symptom or DTC goes away, the injector is faulty. Only after the other inspection items indicate a normal condition does this path call the remaining PCM the cause. For verification, do not change the confirmation logic. Use the captured operating conditions where applicable, watch the same fuel trim response, and make sure the rich failure is no longer duplicated. The takeaway is simple. Do not clear the data early, duplicate the rich condition first, and work through fuel pressure, airflow, oil contamination, purge, fuel quality, /F feedback, and injectors before judging the PCM. For more diagnostic training, visit stepdiagnostics.com.